Hey everyone, welcome back to the channel where math becomes super simple. You are all welcome to the Mental Maths channel. Today, I'll be diving into indices. Don't worry if this sounds scary, because by the end of this video, you'll be solving indices problems like a pro. And if I can make you love indices, you've got to do just one thing for me. Hit that like button, subscribe and share so that YouTube will show this video to as many people that might be having problems with indices, especially people who struggle with maths. Let's grow smarter together. I will try as much as possible to break the laws of indices to make it simple enough for you to understand. First thing first, what exactly are indices? Indices, simply put, or exponent as explained sometimes, are simply a short way of writing repeated multiplication. So take for example, we have 2 raised to power 2 to the power of 3, something like this. 2 to the power of 3 means 2 times 2 times 2. That's 2 in 3 places. Now, in like manner, we have 5 raised to power 4, meaning we are multiplying 5 4 times. That is 5 times 5 times 5 times 5. That's what 5 raised to power means. So instead of writing a long multiplication, we write a base and an index. The small number at the top is called the index. Like for instance, in this example, we have 10 raised to the power of 2. 10 is the base. This is the base, and 2 is the index. So we have laws governing indices. All you need to do just to get over this is just to understand the laws of indices, as it were. I will try as much as possible to make it as simple as possible. Okay, so here we start. So the very first law of indices says x raised to power a times x raised to power b equals x raised to power a plus b. So I would try as much as possible to make it simple. So let's take, for instance, we have a problem like 2 raised to power 2 to the power of 3. Sorry, I didn't write that 3 very well. I'm so sorry for that. Let me write it. I want to erase this 3. Okay, I've erased everything. Okay, I'm starting again. So I'm taking this as an example. Say 2 raised to power 3. So times 2 raised to power 4. What this means is simply 2 in 3 places and another 2 in 4 places. So in all, we can count the number of 2s we have here. We have the first 2 here: 1, 2, 3, 4, 5, 6, 7. So this gives us 2 into 7 places. That is 2 appearing 7 times. 7 here is the index, 2 is the base, meaning 2 appearing 7 times. So instead of simply writing it out, spelling it out like this, we can simply just indicate the common base. The common base in this exercise here is 2. So we have 2 as the common base. Then simply add the powers, that is 3 plus. So in indices, times is plus. 3 plus 4. So that will give us 2 to the power of 7. 2 to the power of 7. 2 to the power of 7. So let's quickly go through another example. Another example, so you understand it. That's the first law of indices. So another example, we have 5 raised to power 3 times 5 raised to power maybe 4 again. So this literally means 5 raised to power 3 means 5 3 times. 5 times 5 times 5. Then multiplied by 5 into 4 places. 5 times 5 times 5 times 5. So how many times does 5 appear? So we can see here that 5 appears 1, 2, 3, 4, 5, 6, 7. That's 5 raised to power 7. 5 raised to power 7. So instead of writing it, spelling it out like this, all we need to do is to locate the common base. We have a 5 here. We have another 5 here. That's the common base. Common base. That's 5. Then we simply add the indices because of the multiplication in between. That's 3 plus 4. And that will give us 5 to the power of 7. So I believe that is understood. So let's on that note, let's go to the second law of indices, which says that x raised to power a divided by x raised to power b equals x raised to power a minus b. So let's give an instance. So let's take for instance, we have 3 to the power of 4 divided by 3 to the power of 2. So what this means, literally means 3 in 4 places, 3 times 3 times 3 times 3. That's 3 into 4 places, then divided by 3 into 2 places. That's 3 appearing 2 times. All we need to do is just to cancel this 3, cancel this 3, this 3 cancels this 3, and we are left with 3 times 3, that is 9, which is the same thing as 3 appearing 2 times. 2 times. So instead of going through this route, all we needed to have done would have just been 3 in. So when there is a division in indices, division is minus. Just write the index 4, then minus 2, and that will give you 3 raised to the power of 2, which is still the same as this. This is a quicker way. So indices is just a quicker way of representing continuous multiples of numbers. So in that wise, let's go to the third law of indices, which says that any number raised to the power of 0, no matter the number, is 1. Any number raised to the power of 0, no matter the number, is 1. So what that means that 2 raised to the power 0 is 1. Just note all this. 3 raised to the power 0 is 1. 4 raised to the power 0 is 1. 1000 raised to the power 0 is 1. 1 million raised to the power of 0 is 1. Any number, no matter what it is, raised to the power 0 is 1, except 0. The number must not be equal to 0. 0 raised to the power 0 is undefined. 0 raised to the power 0 is undefined. So you just have to memorize these laws to guide you. 0 raised to the power 0 is undefined. So any other number raised to the power 0 is 1. Just memorize this law. Any number raised to the power 0 is 1. 2 raised to the power 0 is 1. 5 raised to the power 0 is 1. 10 raised to the power 0 is 1. No matter the number. 10 million raised to the power 0 is 1. 1 billion raised to the power 0 is 1. Just note that. Once you know that, you'll be fine. So that takes us to the next law of indices. We'll be solving some examples. I've prepared some examples for us, so so that we'll understand better. So the next law says that x raised to the power a is 1 over x raised to the power a. What that means in essence, just giving you like 2 examples. So when we have 3 raised to the power of minus 2, note that before this 3 raised to the power minus 2, let's say 3 raised to the power 2 from my earlier explanation is 3 times 3. That is 3 in 2 places. But when there is a minus, it is the reverse. That is the reverse. Now 3 raised to the power 3 is 3 times 3. Then 3 raised to the power of minus 2. All you need to do is, the very first thing, this minus, convert it to 1 like this. 1. Then say divided by. So this minus, you will replace 1 divided by 3. Then you remove the minus, then to the power of 2. And that will give you 1 over 9. 1 over 9. So let's, in like manner, just solve one or two more. Okay, 1 or 2 more. So we have 4 raised to the power minus 3. 4 raised to the power minus 3 will now be what? 1 over 4 raised to the power 3. So provided we have this minus sign in between, that's the index. Minus sign, that's a negative index. So all you need to do is just to find more like a reciprocal of that number. So we have 1 it will default into the 1 over 4 raised to power 3. There won't be any minus again. So it's just 1 over 4 raised to power 3. You can write this as 1 over 4 times 4 times 4. 4 times 4 times 4. And that will give you 1 over 64. 1 over 64. 1 over 64. So let's continue. This is just the part 1 of the law of indices. We'll still delve more into the part 2, but I just want to set the ball rolling so that we understand what we are going into. So I will stop at the 5th law. In my part 2, I will deliberate more on the 6th and the 7th law. So let's just quickly go into the 6th law of indices and the 5th law of indices, which says that x raised to power a in bracket b, like this, something like this. So this is the same thing as what? X raised to power a b. Just know the law of indices. X raised to power a b, meaning you just multiply the indices, that is the a, multiply the a and the b, while the x, you write the x as it is. So let's just take 3 examples to explain this. Before we go into today's problem. So we'll be solving as many exercises as possible. So if we are given something like 2 raised to power 3 into bracket 2 outside, all you need to do is to rewrite what this means. This means in bracket means 2 raised to power 3 appearing 2 times. That is 2 raised to power 3 appearing 2 times. 2 raised to power 3 appearing 2 times. That's what it means. So this is the same meaning of this is 2 raised to power 3 appearing 2 times. And don't forget, this is 2. There is 2 here. So we look for a common base of 2. Then simply add the powers 3 because of times default into plus in indices. So you just add the powers. You have 3 plus 3, and that will give you 2 raised to power 6. 2 raised to power 6. Rather than go through this long method, what we ought to have done would have just been write the base 2 out because it's in the bracket, base 2 out, then simply multiply the indices or the indices, that's 3 and 2, and that will give you 6, and that solves it. Okay, so let's go into today's exercises so you will understand better. So I will be bringing in the second part of these exercises in now so that we solve these questions together. Okay. So these are the exercises we'll be solving together. We'll quickly go through them one after the other. So the very first one, we have 10 raised to power 2 times 10 raised to power 3. So we have 10 raised to power 2 times 10 raised to power 3. How do we solve this? Don't forget that in the law of indices, the first law, times, anytime you see a times, it defaults into plus. That is plus, addition. It defaults into addition. Now the next thing to note is is there a common base? 10 is a base, 2 is an index, 10 is another base, and 3 is an index. There is a common base of 10 here, and there is a common base of 10 here. So we have 10 is common amongst the two. So we simply write 1 10 out. So all you need to do is just to add this 2 to this 3 because of this times plus. So that will be 2 plus 3, and that will give you 10 raised to power 5. 10 raised to power 5. That's the answer, 10 raised to power 5. If you had wanted to go through the long route, what this means in essence is 10 times 10, 10 times 10, then multiply by another 10 in 3 places, 10 times 10 times 10. And if you count the number of 10, we have 1, 2, 3, 4, 5, and that will give you 10 raised to power 5. 10 raised to power 5. Okay, that solves that. So let's quickly go to number 2. Let's quickly go to number 2 so we don't spend too much time on this. So number 2, we have 36 n squared, 36 n raised to power 2 divided by 2n raised to power 3. The very first thing, like I said, to note is that because it's a division defaults into minus. In that's the law of indices. Then we have a n here, which is a base, a common base, and you have another n here, which is another common base. So, but before then, before this n square, in front of this n square, we have a number 36. We have the number 36 here, and we have a number 2 here. So what you need to do is just to simply divide 36 by 2. Divide 36 by 2, and that will give you 18. 18, 18, 18. So we have 18n squared divided by n raised to power 3. And don't forget the second law of indices. So n squared divided by n raised to power 3. What that means is that it means 18 it means 18n raised to power 2 divided by n raised to power 3. So you simply, all you need to do is just to subtract. Because of this division, it divides into minus. That's 2 minus 3. That will be 18 and 2 minus 3, and that will give you like 18 n raised to power minus 1, and that is the answer. And that is the answer. And that is the answer. If you were to rewrite this, you would have written this as 36 n squared divided by 2 n raised to power 3. So 2 goes here into 36, 18, and this means 18 n squared over n raised to power 3. This also means 18 times n over n times n times n, meaning n into 3 places and n into 2 places. So this n cancels this n cancels this n, and we have left with 18 over n, which is the same thing as 18 n raised to power minus 1. 18 n raised to power minus 1. So number 3, let's go to number 3. Let's quickly go to number 3. Let's solve number 3 question, the third question on the list. So for the third question on the list, 20 raised to power 0. We have a question 20 raised to power 0. The answer here is 1, because any number raised to power 0 is what? Is 1. That solves that. Any number raised to power 0 other than 0. 0 raised to power 0, don't forget it's undefined. Just memorize the laws. Once you memorize the laws, you'll be fine. Number 4, 10 raised to power minus 2. 10 raised to power minus 2. 10 raised to power minus 2. I said if you are to rewrite this, you would use a reciprocal. Reciprocal means you put 1 up divided by 10 raised to power 2. Simple. Which is the same thing as what? 1 over 10 raised to power 2 is 10 times 10. That's 100. 1 over 100. Simple. That solves that. Number 5. So we have number 5, we have r times r squared times r raised to power 3 times r raised to power minus 3. Now, the power here, if it's not written, is 1. This one means 1. The index here is 2. The index here is 3. And the index here is minus 3. We have a common base of r. R is common here, r is here, r is here, r is here. So simply write just one r out. Then the next thing to do, add the powers. That is, the index is 1. Because of these times, it becomes plus 1 plus 2 plus 3 minus 3. 1 plus 2 plus 3 minus 3. And that will give you r. That's 3 plus 3, 6 minus 3. That's 3. 3 minus 3 is 0. 1 plus 2 is 3. So this means r times r times r. So that solves that. So if you've gotten value up to this point, please, this is a new channel dedicated to helping students with maths, helping people with maths problem, and also taking them through mental mathematics, more like simplifying, showing you ways of going through difficult multiplication, addition, subtraction, division, and what have you, mathematics, just making it simpler in a way you would have least expected. So in subsequent videos, you will see how I'm going to break down multiplication like never before. but today we are treating indices. So if you've gotten value up to this point, please consider like, share and subscribe to my channel so that you'll be receiving alert from YouTube as soon as I release more videos. And I would want you to share this with your friends. So to share it with your friend who is having problem with mathematics. Mathematics is simple, it's just basic understanding. So let's go to number 6. For number 6, we have minus 4d raised to power 3 raised 2. So what this means, so if you have a number in bracket, this is the simple way to go about it. Once you have a number in bracket, so what you will have to do is to raise each of the numbers, that is each number, to the power of 2. That is, minus 4 is raised to the power of 2. Minus 4, you take them one by one after the other. Minus 4 is raised to power 2. Minus 4 is raised to power 2. And the d, which is already raised to power 3, is also raised to power 2. So it's just like you bringing out each number that's each number out and raising each number to the power of 2. Minus 4 raised to power 2 is the same as minus 4 times minus 4, and that will give you 16. Then d raised to power 3 to the power of 2. D raised to power 3 to the power of 2 will give you d raised to power, don't forget the law of indices, 3 times 2. So d raised to power 3 to the power of 2 means d raised to power 3 in 2 places. So that will give you d raised to power 6. And that solves it. This is the answer. So let's go to the next one. The next one is number 7. Number 7. So for number 7, we have numbers in bracket again. We have minus a squared m raised to power 4. So inside the brackets, we can identify a minus, an a squared, and an m. Minus a squared and m. Minus a squared and m. So when minus is raised to the power of 4, that is, minus times minus is plus, times minus it becomes minus, and minus again becomes plus. So that will be minus. So that will, if you want to break it down, you say minus a squared to the power of this 4. This number will be raised to the power of this 4. M also will be raised to the power of 4. You just split them. So minus a squared will be raised to the power of 4, and m itself will be raised to the power of 4. So minus a squared raised to the power of 4 will give you a squared times 4. That's 2 times 4. 2 times 4 will give you 8. Minus into 4 places. Minus into 4 places will give you a positive. So that positive a raised to the power 8. Then we have m raised to the power 4. So the answer is a raised to the power 8, m raised to the power 4. So that solves that. Don't forget, when you have numbers in brackets, identify each as a constituent, that each member of that bracket, you need to bring each member of that bracket out and raise each member to that power. Just know it like that. That number 8. So we have minus 3, and we have d e raised to power 3 and raised to power 4. Now to solve this one, minus 3 is not contained in the bracket. So what we need to do is just to write minus 3 is not contained in the bracket. It will be times. Now the constituent in the bracket, that's the base. You consider the base, not the index. The base, we have d and we have e. D and e. So the d will be raised to, d is raised to power 1. Once the power is not indicated, it is power 1. D is raised to power 1. So 1 will multiply this 4, and that will be d raised to power 4. Then the e is already raised to power 3. 3 will multiply this 4. 3 will multiply this 4, and that will give you e raised to power 12. And the answer will give you minus 3 d raised to power 4 e raised to the power 12. Don't forget that the minus 3 is not in the bracket. If the minus 3 were to be in the bracket, it should have been minus 3 raised to the power 4. But because minus 3 is not in the bracket, it stands out on its own. You only consider the elements that are inside the bracket. So you consider them base by base, and that solves question number 8. Now let's go to question number 9. Question number 9. Hope you are getting value from what I am teaching today. If you are, please consider to like, share, and to subscribe to my channel. So question number 9, 2 is power 3 times 1 over 6 raised to power minus 1. Let's solve this one first. This one looks like a tough calculation. So what is 1 over 6 raised to power minus 1? When we have 1 over 6 raised to power minus 1, don't forget the law of indices. It means 1, like I said, is 1 reciprocal divided by 1 over 6 raised to power 1. And 1 over any number raised to power 1 is still that same number. 1 divided by 1 over 6 raised to power 1. So and that will give you 1 over 1 over 6. And what is 1 over 1 over 6? That's 1 divided by 1 over 6. And that will be what? 1 times 6 over 1. And that will give you 6. So we are not done yet. Don't forget the question again is 2 raised to power 3 times 6. And that will give you 8 times 6. And that will give you 48. So 48 is the answer. 48 is the answer. 48 is the answer. So lastly, let's go to question number 10. Question number 10. And we'll round it up for today. Question number 10. We have 5x squared times 4x squared times 2x raised to the power minus 6. So the coefficient means number in front of the letters. Coefficient of x squared is 5. Coefficient of x squared here is 4. Coefficient of x raised to the power minus 6 is 2. So basically what you need to do is just to multiply those three numbers, 5, 4, 2. Because of this times here. 5 times 4, 20 times 2, 40. So that gives you 40. Now, we have a common base. Don't forget x is the base and 2 is the index here, 2 is the index here, and minus 6 is the index here. So there is a common base of x here, x here, x here. You pick just one x. Then you add the powers, the base, you add the bases. That's 2, because in indices times is plus, it becomes plus 2, then minus 6. And why is it minus 6? Because plus times minus is minus. Plus times minus is minus. So we have 40x. 2 plus 2 is 4. 4 minus 6 is minus 2. So the answer is 40x raised to the power minus 2. 40x raised to the power minus 2. 40x raised to the power minus 2. So we've solved. This is just the part 1 of the law of indices. Part 1. So we'll be going through as many examples in my subsequent videos. So I want to believe you've understood it. If you've not understood it, just let me know what your questions are. You can drop your questions for me in the chat box below, and I will find time to attend to it. But be that as it may, I have some questions, take-home assignments for you just to practice. So this is the take-home assignment. So to solve this, just solve it, and comment your answers in the comment box below. And I would go through it, and we'll go over it in our next video before we go into the part 2 of the law of indices. At this juncture, I would want to call it a day here, but before then, please, like I said, this is a new channel dedicated to math, mental math. You'll be learning a lot by subscribing to my channel. So don't just watch it, I would urge you to practice. You can go over it again, watch it over again if not gotten anything. But all the same, if you still need some clarity, just drop a comment in the chat box so that I will compile your questions and we'll go over it and go over the solved solutions. So thank you very much for making it a day with me today. I want to believe next class would delve more and solve quite a number of questions. Just like I said, the dream of this channel is to make maths simple, simple enough, even a dummy would understand it. Thank you so very much.